Let us talk about the next topic, which is the decision tree as our very first classification algorithm. It follows the same logic of the training stage and then goes into the prediction stage. So decision tree gives you a very understandable training model to be looked into so that you can totally understand how does the decision or the prediction be made. So let's take a look of the decision tree. Decision tree induction is a learning of decision trees from class labeled training tuples. A decision tree is like a flowchart. It will start with the root. That is the topic discussed in data structure. Starting from the root, making the decisions goes to each branch and then make the decisions. So every internal node of the decision tree denotes as a test on an attribute, and then each branch represents the outcome of the test. And when it finally reaches the leaf node, it's indicating a class label that this decision tree predicts. So here gives you a very quick example of that. Based on the data set that we talk about using the age, income, as well as the credit scores, etc. We try to predict whether or not a customer will going to buy a computer. So you can see this is a decision tree generated based on that data set, and we will go through every steps here to understand how does each branch, internal node, as well as the leaf node denoted in this decision tree. So what this is trying to do is that when using the training data set, this decision tree was constructed. So when it comes to a prediction stage, for any prediction data that comes in, we will look into the age attribute. If the age is young, then it will come to if that is a student. If that data is a student, then it will buy a computer. If not a student, it will not going to buy a computer. On the other side, if the age equals to middle age, it is no doubt it will buy a computer without any other testings. If the age is senior, if that person has an excellent credit, then it's not going to make any computer purchase. And if that's fair, then you will buy a computer. You need to understand this decision tree is not creating a common sense structure. This decision tree is based on the training data set that we feed into, and it will create to reflect the facts that this training data set represents. And so that when the unknown data set comes in, it will just use this tree to make the predictions. And like I mentioned earlier, this is what we call a white box classification algorithm because you can easily understand how this prediction is made. So the basic algorithm is a greedy algorithm. Tree is constructed in a top-down approach. So you were starting from the root, try to find the best choice at that stage, and then based on the answers, it will try to do what we call a recursive divide and conquer manner to build the next level of the decision. And then it will come to the next level and next level until a certain base case scenario has been hit so that it will stop the branch divisions. So at start, all the training examples are at the root. Attributes are categorical. So if they are continuous value, this has to be changed into a category. So it can be two categories, three categories, but you need to separate that. And therefore, you can see that in the data set, and which we will quickly see, for the age is divided into young, middle, and senior. So all the things need to be separated into category, and that's how decision tree algorithm works. So that is part of the data pre-processing. How do you process such as age, income, credit score, those things into a categorical data so that decision tree can work. Test attributes are selected on the basis of the heuristic or statistical methods. And then how do we make the decision at each level? We use something called information gain, and that is the mathematical backgrounds that we need to look into so that we can make the best choice. Because remember, this algorithm is a greedy algorithm, so that we need to have a number to help us make the decision which one is the best choice at the root and at the next level as well as the next level after that. So let's take a look of this data set one more time. This time you will see things slightly differently when you see this data for the first time. We still have 5 columns over here if we use the last column as our label, which means that we want to make a prediction of a customer going to buy a computer or not. Then we will have using the first 4 attributes to make our decisions. In other words, starting from the root node, you have 4 choices. You can either choose you want to use age as the first division, branch, or income, or student, or credit rating. So we need to calculate something, and that's what we call an information gain, to see which one that we use can give us the highest gain, and we will use that as our root testing branch. And another thing that you need to understand is that each data is in category. So age has 3 categories. Income has 3 categories. Student has 2 categories. Credit rating has 2 categories as well. Of course, based on the realistic data set, credit rating can be like 5 different categories. Income can be divided in like 10 different categories. All of those are fine, but these things need to be decided before the decision tree is being applied. So you see, this is going to be a part of the data pre-processing topic need to be implemented before the classification model has been tested. So now let's see, how can we make our decision saying that which one is the best attribute for us to start. So what we need to see is that we need to select the attribute with highest information gain. That means we can gain lots of information from that attribute. So saying that the PI be the probability that an arbitrary tuple in D belongs to class CI estimated by CI, D divided by the number of D cases. Then the expected information, or what we call entropy, is going to be described as the following things. The information or the entropy equals to, first of all, let's take a look at this one. The probability of that value multiply log 2 of the same probability. Depending on how many categories that you have in that attribute or that label, we need to calculate that amount of time and it sums all of those things up. One more thing you need to pay attention is that since the probability is always less than 1, after you take log 2 of a value that's less than 1, you will get a negative value. That's why we have a negative value in front of it. So we basically try to sum up all the values of the different categories in that label, and then that is our what we call entropy.